Hello there and welcome to Lower 6 Maths A-Level Practice Paper B. Here we're working on question 12. The diagram shows part of a curve with the equation y equals x squared minus 8x plus 20 and part of the line at y equals x plus 6. Using the appropriate algebraic method to find the coordinates to A and B. Okay, well, classic way of finding the intersection points between two lines is just to set the equations of those lines equal to each other. So here we get that. So let's move everything on to y to form that quadratic. So it's going to be 8. So x squared, take away another x, that's minus 9x, and take away 6, that will give us plus 14. Factorise it, x minus 7, x minus 2. Two positive solutions are going to come out of this. X equals plus 7 and x equals plus 2. That makes sense. So we have one coordinate here of 2 and one coordinate here of 7. But it does say the coordinates, so we do need to work them out. So for the x equals 7 coordinate, the y coordinate is just going to be add on 6, that would be 13. So we have a 7, 13 coordinate. And when x equals 2, add on 6 and we get an 8. So it would be 2, 8. So I've used the second equation here as it was the easiest one to work out the y coordinate for. Okay, so we have coordinates of 2 and 7 here, with a height of 13 and 8. So 8 here and 13 here. Okay, find the exact value of the area of the region defined by the x-axis. The line y equals xa, the line y equals xb, that's the 2 and the 7 it's referring to here, and the line AB. So it's the area that's formed by this shape here. As far as I can see, the easiest way to do that would just be to use the formula for the area of a trapezium. So the area of the formula of trapezium is half a plus b times h. H is the height, so this would be h from here to here, and a and b would be the heights of a and b there. So we're going to get half of 2 plus 7 multiplied by, so not 2 plus 5, it's going to be the heights of these lines, isn't it? So it's going to be a half of 8 plus 13 times by a height of this line here of 5. So we're going to get 52.5. Okay, great. Next question. Use calculus to find the exact area of the finite region bounded by the x-axis, the x equals a and x equals b, and the curve of this area. So we're looking for underneath this line here, that line x equals xb and x equals xa, so that's 2 and a 7. We need to find this area under the graph here. I assume what they're looking for us to do is then take away that from an area of a trapezium to leave us with the red area. So part C is looking for the area underneath a curve. So the area under a curve is calculated by doing integration. So it's the integral from 7 to 2 of the curve x squared minus 8x plus 20. Okay, so we have to integrate now. So remember, the rule is if you've got xn to integrate, you increase the power by 1, so it turns into an x plus 1, and then you divide by the new power, n plus 1. So it's going to be x3, and then you divide by the 3, minus 8x squared, and you divide by the 2. Plus 20x, and you divide by the 1, which we don't really need to do. And that's going to be bounded in between 7 to 2. And the way that we calculate this is we plug 7 into the x values here first, then we subtract 2 being substituted into this formula here as well. So it's going to be 7 cubed over 3 minus 8 lots of 7 squared over 2 plus 20 lots of 7, and then it's going to be 2 cubed over 3 minus 8 lots of 2 squared over 2 plus 20 lots of 2. And the answer to that is, grab your calculator, and what we can do with our calculator here is we can go straight from our integral symbol between 7 to 2 using this button here that gives us an integral. Use your up and down arrows, use the button for x to highlight your x values here, and we get there 95 over 3. So 95 over 3 there. So that's the value of this shaded region that I've done in my pen here. Part D is find the value to one decimal place, the area shaded by the region enclosed by this curve and the line AB. So now we're looking for this red area here. This area here that's not been highlighted because my pen is red. Okay, so let's work backwards a page. We had 52.5 up here. So 52.5 is the area of the trapezium, and we've got to take away 95 over 3. And that's going to give us 20.8 units squared to one decimal place. Okay, great, that's 13 marks for that question.